Hello everyone, I'm Xiao Gang. Okay, in this lesson, we will start parsing the received information. As you can see, this information is a very long string, so we won't let it print 2G of information. So what does the received information look like? Actually, the long information looks like this. This is an explanation identifier for data upload. Ignore it. Mainly look at this. The information is like this. You judge whether it has been completed based on this stage, right? So we need to parse this information. How to parse it? Still our usual approach. We prepare a respond info here. This is the information it sent over. If we don't have this struct yet, then we go to this type. This type should be here. Inside this type, let's write out this struct. What does this struct look like? It actually looks like this. Let me show you. Okay, this struct contains another data struct inside it. So this data refers to this one here. Let me zoom out a bit. We'll delete these comments. These comments are useless. Just read the Chinese documentation directly. Okay, this side is get. We'll ignore it. Okay, so this is a struct. Then we'll need to change the derivative red here. We'll change it later. Let's copy the specific data above over. Then delete the comments. Okay, the parameter we are most concerned about is this one. This parameter is their data. Audio data. Then we export the red here. Okay, once we have this export red, then in this place, we include its reflection file here. Okay, once that's done, our struct is ready. Next, let's go back to our message side. Okay, now that we have this information, we need to judge the fields within the information. Generally, when we receive the information, there's no issue on our end. We just need to ensure that this code equals 0. If it's not equal to 0, it indicates a failure. If it fails, we need to record the failure information because it may contain information about other failure factors. So we will take this parsed message drawing ID code and put it in. Because it draws, it may have failed. It only needs to be sent once, right? Then we transfer this information to our blueprint. At this point, if we fail, we manually close. The methods inside have already been written by us. These processes you can see already written. Then this place passes a null pointer. Look here, this place gives a null pointer. It should be here. It is empty by default. No need to write. Okay, good. If successful, we need to differentiate because we are flowing. If your downstream interface receives streaming data, then it becomes particularly troublesome to handle it. That is, you need to call the milkshake or call other pipelines to send out the streaming PCM. And we have an integrated streaming here because our downstream interface actually receives a whole segment of audio as a downstream interface. So we don't need to make it streaming. Then we only need to parse it each time because it is streaming. So we first get this data. There will actually be copying here, a bit of overhead. You can optimize it yourself later. Obviously, this audio is very large. Very large is a good word. Make a copy of it here. Then that wouldn't be appropriate. But for the convenience of reading and writing, it's fine to write it this way. Then let's take a look. Check if its state is correct. Generally, it only has two states, 1 and 2. If its state is incorrect, it indicates a problem. We won't execute the following parts. We'll just let it stop here because it only has states 1 and 2. Actually, if this kind of problem occurs here, you'd better check it. We didn't handle this on our end. Then let's first determine whether the current character is not empty, and then whether this state is correct. If it is correct, then we need to decode this data decode it into our binary data. Then we prepare a binary data. Then we use base64 to directly decode this string into binary data. Then we append this to our data here. What is this? This is all the data we have accumulated, coming in segment by segment. This way, we have our data processed. Then at this point, we check whether this is the last round of transmission. If it is the last round of transmission, it means we need to synthesize this data. First, we check if it is stored locally. If it is stored locally, We then execute this asynchronous WA. We won't worry about this operation for now. We'll execute it later. Here, we assume we have already executed this operation. This operation is called asynchronously, so we don't need to worry about it. Then, at this point, we need to create a method for the external sorrow. So how do we do it? We call this method. We haven't written this method yet, right? We just write it into this. A SIP action. We pass this data to this method. This method will output a USoundWave. Then here, we print a log because we have completed a synthesis here. Yes, this time it was successful. Then, and pass all this log information out. That is to tell the blueprint that we have successfully synthesized it. And this object is ready for you to use. And here, because we are worried that this frame might be destroyed, so we have it added to the parent in this frame. And then remove it in the next frame. Then pass this object to the blueprint if the blueprint no longer needs it. Then in the next frame, or the frame after that, it will be recycled. Just leave it alone. Then here, let's turn off the WebSocket again, because we've finished using it. Now we mainly need to write this PCM method. Okay, writing this PCM method is a bit troublesome. Let's put it here, okay? Because this PCM method has many different ways to write it. We'll expand on this knowledge later for everyone. Currently, this method is in version 4.20. We need to annotate it. In version 5.4.3 and 5.4.4 cannot be used normally. Make a note for him. If this place is not successful, if what you put out here is abnormal, then you don't need to worry about it. Because this is how it is. Because later I'll find some time to add a procedural audio. I've never had time to do this. First of all, this channel of ours is definitely because the data format it sends. This is the data. You can see this is what we set here. We have 6K and a single channel PCM. Such data, this is defined in recruit info by us, and here we have 2 bits. So our size of sample is 2 bytes, and how many sample points it has. That is actually this data. That is our PCM data. This is the sample point. This is the sampling point. So we have the total data. Divide by how large each piece of data is. Data this size. Later, 1 sampling point lies between 2. So this gives the total number of sampling points. So how many ferments does it have in total? Actually, it is divided by this channel. So it is 1 channel. Actually, these two are the same. But the meanings they represent are different because you have a single channel. For a single channel, the sampling point and this form are essentially the same. Then, regarding our size, it is actually this. The size of the entire data is this large, right? We'll just give it a name here. We'll call it something like Xiaogang Survive. Okay. Then here we directly use NewObject. And here we just give it 2 RF flags. For example, public, standalone, etc. Okay. So at this point, what do we need to do? We need to check the version. If this version is in the editor, and is version 5.10 or later, then you need to update our editor data here. This part is quite complex. Everyone can ignore it. So we need to convert this data into WAV format data. We haven't written this part yet. Let's ignore it for now. Okay, assuming this data here has already been converted to WA. Then we call this SoundWaveObject. Then we take this data in this way and put this WAV data only into this UObject, this inside. Only then can you, under the editor, perform a payback. Then we will prepare a method here to convert the PCM data into WAV data. We don't have it yet, so let's stop here. For now, okay, this is what needs to be done under the editor. If you are not under the editor, then at this point, first, what? You need to allocate a memory region of this size for the location pointed to by this pointer, the location pointed to by this pointer, or that pointer. Then you take this memory area, this data, copy out PCM data into it. You can see this is the PCM data pointer, this is the PCM data length, and this is the newly allocated memory area. You copy it in after copying it in. Then you also specify the size. After specifying it, then update this information. For example, the duration, sample rate, number of channels, and the number of sample points, you update them. After updating, return this object again. Then this will be fine. This way, it can be completed. Then our main focus here is next. Regarding this PCM part, let's further refine this thing for everyone. So how should this PM be done? I will guide everyone through writing it here. In the next lesson, I will guide everyone through writing it.